Hi guys, how are you? I'm good. This is Jarsos Lectures. By this video, I bring you one very important point, which is about algorithm description. Before starting, if you are new to my YouTube channel, don't forget to subscribe my channel, to like my videos, and to share the channel link and the videos link with your friends. Our today's topic is about algorithm description. Let us see what is algorithms, by what thing or by what methods or by what technique we can describe an algorithms. Uh, Algorithm is sequence of unambiguous instruction for solving a problem. When you say algorithm means step by step procedure, step by step process of solving problems simply. This is simple. Step by step, but it is simple. Step by step. In simple term, it is step by step procedures of solving problems. In that step by steps, one precedes the others. Starting point is there and the end point is there. So this step by step process of solving problem is what we call an algorithm. It is lists of instructions specifying precise descriptions of step by step process. Look, step by step process that terminates after a finite number of steps. As I have already said, there is a starting point of algorithm to write an algorithm, to describe an algorithm, even within a pseudocode or within a flowchart. There is a starting point and the ending point. Start and the end is here. So, algorithm is step by step process which can be finalized after certain steps. I mean that one of the basic characteristics of or the basic properties of algorithm is that it is finiteness. It is finite. It is finiteness. After finite numbers of steps, after finite numbers of activities, it can be finalized. Then producing the correct answer at the end. Finite sets of instructions that specify sequence of operation to be carried out in order to solve specific problem is what you call an algorithm. This is an algorithm. What algorithm is? It is actually finite numbers of, can be 2, 3, can be 4, can be 5, finite, but what you have to know is that it is finite. One of its properties, it is finiteness. Algorithm is finite. So step by step procedures, step by step process of solving a problem is what you call an algorithm. Look here, an ambiguous procedure specifying finite number of steps to be taken is what you call algorithm. One very important point, look here, bear in mind please. It is precise and independent of specific programming languages. It is not dependent on programming languages. If for example, to solve a problem, for example, to write a programs, it is better, it is uh, suitable first, or it is best. What I want to tell you here is that to write certain programs, if you write first it is algorithm, it is good. After writing an algorithms, it is simple to write the program from the written algorithms. After writing an algorithms, it is simple. We can simply shift, we can simply change, we can simply convert the written algorithms into programs. And this algorithm is independent of any programming language. For example, for C++ programming, for C++ program, for Java, for any others, we can write first algorithm to write a programs in order to simplify writings of our code, in order to simplify writings of our source code, in order to simplify writings of our source program. It is simple first, it is good, yeah, it is better first to write algorithm. Then after writing an algorithm, it is simple now to change that or to shift that algorithms into the program. It is a procedure or formula, which we can say, for solving problem. As I have said, it is a procedure or process, which we can say, or techniques or formula for solving a problem. The other thing is that there are two commonly tools, two commonly techniques, two commonly procedure to write or to describe an algorithm. Those two procedures, those two techniques are flowcharts and the pseudocode. Another's can be also there, but the major, the basic one, the commonly usable techniques to describe an algorithm is flowchart and the pseudocode. But another like that of structured chart can be theirs. But those two are what? The common pseudocode and the flowcharts are the common tools, the common techniques, the common methods to describe an algorithm. Let us see both of them one by one. Flowchart, as the name suggests, as the name describes, chart is here. It is diagrammatic representations of an algorithm, simply diagrammatic representation or graphical representations of an algorithms. Look also flowchart, or also which we can say is spelled flowchart or flowchart, is systematic representations of algorithms or process. It is graphical. Look here, the point is this one. It is a graphical way of representing solution to problems. As I've already said, algorithm is step-by-step procedures, step-by-step process of solving problems. Step-by-step process of solving problems. Now, this flowchart describes, this flowchart represents that step-by-step process by what? By graphical way. By graphical way. By diagrammatic way. By diagrammatic way, it can represent, or it can represent those step-by-step process. Those finite sets of process can be described by graphical or diagrammatic way. In case of what? In case of flowchart. We will see examples. Now look here. The advantages of flowchart is it is doesn't depend on a particular programming language. This is what I have already said. An algorithm, as general algorithm, is not dependent on programming language. For C++ programming language, we can write an algorithm. For Java, we can write. For Python, we can write. So, algorithm is independent of particular or specific programming language, so that it can be used. To translate an algorithm to more than one programming language. Look here. This is the point. After writing one algorithm, that single algorithms can be converted, can be changed to, can be translated into more than one programming language. For example, we can write an algorithms to add two numbers. For example, to add two numbers, we can write an algorithms. Then that algorithms can be changed or can be translated into Java programming language, and they also can be changed into other programming language like that of C++. So it is this algorithm, as general algorithm by itself, is independent of the programming languages. This is the point that we have to bear in our minds. And it uses different symbols. It uses different symbols or geometric shapes to represent different processes. Let us see those symbols within an algorithm. Look, this symbol is named terminal, which is used to represent the starts or the start and the ends of the program. These symbols represents its name is terminal. It is used to terminate what is the starting points of the algorithm and what is the end points of the algorithm within that flowchart. While we are moving through the flowchart, if we reach this one, if we reach these symbols, we have finished the steps. This is started by this one and ended by this one. This is the point. And the other one is input output. The names of this symbol is input output, which seems rectangular, not correct rectangles. But this one is what? The name is input output. Use it to represent input data or output data from the computer. To represent the input into the computers and to represent output from the computer. Always input processes to the computer from outside to inside. This is represented by this symbol, and also the output is from inside to outside. So this is both of them are represented by these symbols. These rectangles, the correct regular rectangles. This is what we call processing. This is what we call processing. Use it to represent computations, which you can say simply. Usually encloses operations or command block a groups of operation or a process. Within that algorithms or within the programs, what computation is there? The computation should be represented by these rectangles. And this one is diamond shaped box, which is decision block. Decision block. If there is a decision, for example, to decide either something is true or false, to decide either the number is positive or negative, to decide which number is greater among the three or two numbers. If there is a decision, we use this decision or this diamond shaped box as a decision. It usually contains question. Within it, there are typically two output paths. Those two output paths are what? Either true or false. Because we have said here, there is a decision, there is a conditions. If condition is true, some output is there. If condition is false, another output is there. Another one is flow line, as you can see. This is a flow line which seems arrow. It is named as flow line. It is used to indicate directions of logical flow. Use it to indicate the directions of logical flow, a path from one operation to another, which the directions of operational flow or the logical flows of the operation. For example, we have said it is step-by-step procedure. Algorithm means step-by-step procedures. If we represent that step-by-step procedure by flowcharts, then one step is before the others. After we finalize one, what is the direction to the next? The step is finite sets of steps are there, and the one step precedes the others. One step precedes the others. So this flow line represents or indicates logical flow, directions of logical flow, to what direction we are moving. After we finalize one step, the next one is which one? What is the next step? To specify or to denote that one, we use flow line. In the on page and the off page is there. On page used to use it for connecting 2-point in connector. A flowchart without drawing flow lines in one page, and another one is off page. This is use it to exit to or any entry from another parts of the flowchart on another. This is the symbols that we can use within a flowchart. Let us see the examples. For example, draw flowchart of an algorithm to add two numbers and display their results. Draw flowchart of an algorithm to add two numbers and display their result. Algorithm description. Look, now to add two numbers, first we have to go those two numbers. What are those two numbers? We have to input. This is now input. For input, we will use this one. This symbol is for input. Look, read the two numbers. First, input or getting two numbers. For example, as all of us are familiar with it, in order to add the two numbers, first we have to know which number we are going to add, which numbers we are going to sum up. So inputting the numbers, and then computation. This one is computation, adding them. Then the third one is assign the sums of those two numbers to the sum. Now here A is one number, B is another number, and the C is sum of them. Now the first step is inputting the numbers or taking the number from either the keyboard or assigning as initial value, entering or taking the input from the environment or from the keyboard, from the outside, inputting or entering two numbers is there, then adding them, and then the third one is assigning their sum to C, and then displaying the result. This is now step-by-step procedure. The first step is there, the second step, the third step, the fourth step. The first step is entering two numbers or having two numbers, which numbers which you are going to add to each other. Then adding them, then assigning their sum to C, and then displaying the result. Let's see by flowchart. Look here. The flowchart is the flowchart to add two numbers. Look, this is start. As I have said, this symbol is for telling us or for showing us for purpose of what? Terminations. Starting, what is starting points of the flowchart tell us, this symbol tell us starting points of the flowchart and the ending points of the flowchart. Look here. Look, this symbol is terminal. Use it to represent the starts of the start and the ends of the program. The start and the starting step, the starting point, and the ending points of our flowchart. Look, our programs start here, end, terminations are there, and then reading, read A and B. Reading means entering two numbers, having two numbers, or getting two numbers, entering two numbers. Now in programs, we can enter from the keyboard. We can assign first as it is initial value. So first reading two numbers means inputting two numbers. Then the next one is adding them. Adding them. Now here they are added, and this step tell us two steps. Within this one, this computation tell us two steps. Look here. Adding them and assigning their sum to C. Look here, C equal to A plus B. This is computation. This symbol is, this rectangle is used to represent computations. Used to represent business logic. Used to represent processing. And this is also output. Look, input and outputs are on the same symbols. Look here. This symbol is for purpose of inputting and outputting. This symbol represents input and output is within the flowchart, as you can see here. Look, this is input, inputting two numbers, adding two numbers, and printing the result on the screens. For example, let us see the program to do this. Okay. Let us see C++ program to do this. Okay, I'm going to write simple C++ program to add two numbers. Include IO stream. Now, by depending upon the algorithm which you have seen now, using namespace std, then int main. What does include our stream means? What does using namespace means? What does int main means? For C++ programs, program structure, I will do another video very soon. Then now declaring our input is A, B, C. Now A and B are two numbers which we are going to add to each other. C is as it is sum. Now taking the input from the keyboard. Look, please enter two numbers. Please enter two numbers. Then here to make it coming on new line. Then cin to take input from the keyboard. Cin A, B. Look, we have started the first step. Look, please enter two number. Here also in our algorithm, look, reading two numbers. Then we have inserted, this is the lines of code to take input from the keyboard. Now after taking the input from the keyboard, the next step is adding them, adding two numbers to each other. Then now the first step is taking the input, entering two numbers. We have inserted here A and B. Then we have added. Then now the next one is printing the result. Printing the result to the computer screen. Printing the result. Then see out the sum of two number is sum. The sum of two numbers is sum. Sorry, here it is C. The sum is C. We have here C equal to A plus B. We have to give here C. The sum of two numbers is C. We have to save it within file extensions of C++. Look, the name, file name dot C++, save. Now, okay. Now here, after I have said, what you have to bear in your mind is that after writing algorithms, either by using flowchart or pseudocode, after writing an algorithms, then writing program is very simple. That's why we use algorithms to solve a step-by-step process of solving the problems. After writing the programs, it is simple to after writing the algorithms, it is simple to write the programs. Look, entering, taking two numbers, or having two numbers. This line of code is to take input from the keyboard, then adding them, and then printing the result. When we compile this one, okay. Here I have forgotten include. Have to be include by saving it. Then compilation. Look here, succeed within 1 minute and 39 seconds. Then let us run. Look, please enter two number. Look, so you can see, please enter two numbers. Then let us enter okay, 8 and 9. Look, the sum of two numbers is 17. The sum of taken number from the keyboard is 17. This is the print result, printing them to the last step. The last step, so within our algorithm is after add them to each other, printing the result to the screen. Then this is what we have seen here within our algorithm using a flowchart. Starting, ending, here reading, taking two numbers, adding them to each other, and the printing C, or which printing the sum. This is how we can write an algorithm. We can write another algorithm by following this. We can write different algorithms. What you have to bear in your mind is that different symbols used for different purpose. This is for termination, for starting and ending points of the algorithms. This is for input and the output. This one is for input and the output. This one is for processing or for computation. This is what we now bear in our mind. And the another symbols are there. And if for example decision is there, we use diamond shaped box. This is what flowchart means. Let us see proceed with the next, which is pseudocode. The other one is pseudocode. Pseudocode is not the same with flowchart. Flowchart uses diagrams, uses geometric shapes to represent steps of within our algorithms. Unlike this one, pseudocode uses different just English statements, English sentences to describe step by step process of our algorithms. Step to describe step within our algorithms. This pseudocode uses uh, English statement is pseudocode, which is derived from pseudo, and the code is compact and the informal high level descriptions of algorithm that uses structural conventions of a programming language. Now, the purpose of using pseudocode is that it may be easier for human to read than conventional programming languages. It is more readable than that of it is simple or it is easier to read than that of programming languages. As I have said already, both pseudocode and the flowchart are what good, or as general algorithm is good. Rather, first before writing program, if you write algorithms of that program, first before writing the programs, writing algorithms of that program is better to write the program again. Later, for writing the program, first if you write algorithm, it is much better, simple to write the programs. First, if you write algorithms, then after to write the programs using different programming language, it is simple. And also writing pseudocode will save your time later during construction and the testing phase of the program development. Before writing the program, if you write first algorithms, either using both pseudocode and the flowchart, it saves your time later for writing the program, for writing, for testing, for debugging the source code. It is simple since it is algorithm is already written first. If you write first the algorithm, it is simple to write the programs, and also it saves your times. Let us see how to write pseudocode. Look here, for example, to add two numbers. This is it is flowchart that we have seen now. It is starting point, input, here output, and this is computation or summing up of them. Look, this is step by step process. Look, begin, this is start, end, look here, stop, reading XY, or taking it from the keyboard. This is simply pseudocode. Writing what you have diagrammatically represented in the flowchart. Writing using those English statements is what we call pseudocode. Look, begin, read, compute, display sum, and end. This is what we call pseudocode. As it is already look, it is informal high level descriptions of algorithms. Okay. The other one is basic control structures. When we write and for example to draw flow charts, maybe sometimes yeah, most of the time conditions are there. Those conditions can be selection condition or can be looping statements. So we use symbols are there, as I have already said. This is conditions. This diamond shaped box is used to represent if there is a conditions or if there is selection conditions. A sequence is series of same statements that execute one after another. This is what you have said. Or algorithms is series of statements that execute one after the other. Selection or branch is used to execute different statements depending on selection condition. Certain condition is there, or which you can say selection condition, by depending upon that selection condition. For example, now to identify either a number is positive or negative, to identify the greatest of two or more numbers, or to print something repeatedly. This is what done by repetition, or looping is used to repeat a statement while certain conditions are met, whether certain conditions are true. For example, if condition is true, we will execute the statements till the condition is true. If the condition is false, it will exit the loop. Now those two selection condition and the control or the loop control structure is what we may face within to draw, for example, flowchart. Let us see their example. For example, largest of two numbers. To identify largest of two numbers, this is it is flowchart, this is the pseudocode. This is flowchart and this is pseudocode. Look here. This is to indicate it is starting point, and this is to indicate it is input. Then now we have inserted two number A and B. Is A greater than B? Look now, there is this question is there. For condition, we use this diamond shaped box. Now, if A is greater than B, if this is true, yes, then we will print A, because we are finding the which one is greater from A and the B. From the two numbers, from the taken number, from the two taken numbers from the keyboard, which one is greater? We are identifying, look, larger of two numbers. Is A greater than B? If yes, directly this is executed, printed to the screen. If no, if A is not greater than B, now the greatest is B. Look, is A greater than B? If yes, A is printed. If no, B is printed. Print B. This both are output. Then stopping our flowchart is. To identify such conditions, we use diamond shaped box. Is A is greater than B? If yes, A is printed. If no, B is printed. Then terminating our flowchart is. Look here, pseudocode. Begin. Read A means taking from the keyboard. If A is greater than B, print A. Else, print B. Look. In case of pseudocode, we use like this one. If A is greater than B, print A. Because we are finding the larger or the greatest. Else means if A is not greater than B, or if B is greater, print B. Then ending or finalizing our pseudocode. This is how to the difference between pseudocode and the flowchart. Flowchart is the diagrammatic or geometric representations of an algorithms, and this one is the algorithm is written by different informal statements. This is all what I have. As summary, we have seen what is an algorithm means. Algorithm is step by step procedures of solving the problems. Now we can describe this algorithm in two ways, either by using flowcharts or pseudocode. Flowchart is using diagrammatic. There are symbols. Each of the reports, the symbols have their own purpose, their own meanings. And another one, pseudocode uses different informal English statements. They look like this one. This is all what I have. If there is any unclear idea, if you have question, if you have suggestion, you can raise for me by putting or by writing it down under the videos, under the comments of or on the comments of this video. And what I want to tell you again is that if you are new to my YouTube channel, don't forget to subscribe my channel, to like my video, and to share the video link and the channel link with your friends. This is all what I have. Thank you for your time. Bye.